Here is a question I want you to sit with for a moment before you answer it. Is 1 a prime number? Think about it honestly. A prime number is divisible only by 1 and itself, and 1 is divisible by 1, and itself is also 1. So 1 satisfies the definition perfectly. Your instinct to say yes is not wrong. It is careful reasoning. You read the definition, you checked every condition, and 1 passes all of them. So then why does every textbook in the world say 1 is not prime? The answer is not what most people expect. It is not that 1 fails some natural test. It is that allowing 1 to be prime breaks something far more important. There is a theorem at the heart of all of number theory. It is called the fundamental theorem of arithmetic. And it says this: every whole number greater than 1 can be written as a product of prime numbers in exactly one way. Take 12. Its prime factorization is 2 times 2 times 3. That is it. No other combination. No other way. Every time you factor 12 into primes, you arrive at the same answer. One unique factorization for every number, always. It is one of the cleanest facts in all of mathematics. Now watch what happens the moment we decide that 1 is prime. Take 12 again. Its factorization is 2 times 2 times 3. But now 1 is prime. So 1 times 2 times 2 times 3 is also a valid prime factorization of 12. And so is 1 times 1 times 2 times 2 times 3. And 1 times 1 times 1 times 2 times 2 times 3. You can keep going forever. 12 now has infinitely many prime factorizations. And so does every other number in existence. Every single one. The theorem that guaranteed every number has one unique prime fingerprint. The theorem the entire structure of number theory is built on collapses completely. Not bends, not stretches, collapses. Because of one small decision. One number allowed into the wrong club. So here is what is really happening. The definition of a prime number is not a neutral description of what primes naturally are. It is a deliberate decision. Mathematicians did not discover that 1 fails some test. They wrote the definition very carefully, very intentionally, in a way that keeps 1 outside the boundary. Because keeping 1 out is the only way to keep the fundamental theorem of arithmetic alive. The definition is a fence, and the fence exists to protect the theorem. And this is true for every definition in mathematics. Every rule that feels arbitrary. Every condition that seems designed to exclude something for no obvious reason. It is a fence. And somewhere behind every fence, there is a theorem that cannot survive without it. The moment you start reading definitions that way, as protective decisions rather than passive descriptions, mathematics stops feeling like a collection of rules you have to memorize and starts feeling like a conversation that has been going on for thousands of years. A conversation where every word was chosen on purpose. 1 is not prime, not because it fails the definition, because mathematicians wrote the definition to make sure it does not. And now you know the difference between a rule and a reason. Which definition do you want to break open next? Drop it in the comments. Like this if it changed how you read a mathematical rule. And subscribe, because every definition has a reason nobody told you about.